Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss trigonometric equations, which are very important questions I am going to discuss in this video. 4 marks questions we will expect compulsory in intermediate mathematics paper 1A. TS and AP, both intermediate boards. The concept is very important. Not only for this, in MSET also we will expect 1 or 2 questions. In JA Mains, this concept will help while solving trigonometric equations. Let us have a discussion. The question here: if tan of pi cos theta equal to cot of pi sin theta, then prove that cos of theta minus pi by 4 is equal to plus or minus 1 by 2 root 2. So this is the equation. They are asking to prove this result. So first, given tan pi cos theta is equal to cot pi sin theta. I want to make both the terms in LHS and RHS in terms of tan. So cot theta, we have formula cot theta equal to, cot theta, tan of pi by 2. Otherwise, in terms of tan we want, no? So here I want to write tan. Tan of pi by 2 minus theta is equal to cot theta. So this is the formula. So this is theta, cot theta. We can write it as, in terms of tan pi cos theta is equal to tan pi by 2 minus pi sin theta. I hope you understand. Tan of pi by 2 minus theta is cot theta only. Whatever it is given, that we can. This is the given equation, dear students. So given, simply we can write it as given. Later on, we have general solution formula. This is theta, this is alpha. Tan theta is equal to tan alpha. Then theta equal to the general solution. Theta equal to n pi plus alpha, where n belongs to z. So this is theta, this is alpha. Therefore, we can write it as pi cos theta is equal to n pi plus alpha. This is alpha value, dear students. So pi by 2 minus pi sin theta. After that, what I am doing is minus pi sin theta I am taking into this side. So pi cos theta plus pi sin theta is equal to the rest of the terms n pi plus pi by 2. Take LCM and simplify. 2 LCM 2n pi plus pi. Take common pi from here. Take common pi from here. Pi into cos theta plus sin theta is equal to pi into 2n plus 1 divided by 2. Both sides pi you have to cancel it. So cos theta plus sin theta is equal to 2n plus 1 divided by 2. After getting up this step, I hope you understand, half of the problem is over. Out of 4 marks till here, you will get 2 marks, dear students. Later on, they are asking to prove cos of theta minus pi by 4 equal to plus or minus 1 by 2 root 2. So, this LHS value I want to make in terms of cos of a minus b. So, whenever the LHS or RHS values a cos theta plus b sin theta form is there, here a value 1, b value is also 1. So to solve these type of equations, dividing on on both sides by root over a square plus b square. So according to this, a value 1, b value 1. So that is the reason root of a square plus b square means root of 1 square plus 1 square. So dividing on both sides by root 2. So 1 by root 2 cos theta plus 1 by root 2 sin theta is equal to 2n plus 1 divided by 2 root 2. I hope you understand why we are dividing on both sides by root 2. This is the way. It is in the form of a cos theta plus b sin theta equal to c. To solve this type of equations, we need to divide on both sides by root over a square plus b square, where a equal to 1, b equal to 1, root 1 square plus 1 square is root 2. So root 2 divided. But this side, LHS, I want to write in terms of cos of a minus b. So this compulsory you should write in terms of cos, here in terms of sin. So 1 by root 2 in terms of cos pi by 4 only, into cos theta plus 1 by root 2 in terms of sin pi by 4 into sin theta is equal to 2n plus 1 divided by 2 root 2. Cos A cos B plus sin A sin B, cos of A minus B. So take first theta. So here we are going to apply this side formula. Cos A cos B plus sin A sin B, this side, is equal to cos of A minus B. So this will becomes cos theta minus pi by 4 is equal to 2n plus 1 divided by 2 root 2. But they are asking to prove plus or minus 1 by 2 root 2. No? You keep that equation number 1. Put n is equal to minus 1 in 1. We get cos theta minus pi by 4 is equal to, n is equal to minus 1 means 2 into minus 1, minus 2 plus 1, minus 1 by 2 root 2. Equation number 2. Put n is equal to 0. These are the special cases, dear students. We get cos of theta minus pi by 4 is equal to 1 by 2 root 2. Equation number 3. From 2 and 3, we conclude that from 2 and 3, we get cos of theta minus pi by 4 is equal to plus or minus 1 by 2 root 2. Hence proved. I hope you understand, dear students. We'll move on to the next question in this session. The next question, this is also general solution related to tan theta equal to tan alpha, dear students. If tan p theta equal to cot q theta, p is not equal to minus q, then show that the solutions are in arithmetic progression with common difference pi by p plus q. So first, as it is, we'll write it. Given tan p theta equal to cot q theta. Tan p theta equal to cot q theta. As we know that cot theta can be written as tan pi by 2 minus theta. So tan p theta is equal to tan pi by 2 minus q theta by applying this formula, dear students. In the next step, since by applying, if tan theta equal to tan alpha, then general solution, then general solution is theta equal to n pi plus alpha, where n belongs to z. So here theta is p theta, alpha is this value. So therefore the general solution p theta is equal to n pi plus pi by 2 minus q theta. Minus q theta I am taking into this side. P theta plus q theta is equal to n pi plus pi by 2. Like previous problem, take LCM here. 2 into n pi, 2n pi plus pi. So pi take common. So from these two also theta take common. Theta into p plus q is equal to pi into 2n plus 1 divided by 2. So I want theta value. Therefore, theta is equal to pi by 2 into 2n plus 1 divided by p plus q, where n belongs to z. They are asking to prove the solutions of this equation are in AP and with common difference pi by p plus q. The solutions of given equation are, first n is equal to 0 I am taking. Like this, n is equal to 0, 1, 2, 3 and so on. If you substitute, dear students, so theta value will become theta equal to, n is equal to 0 if you substitute, pi by 2 into p plus q will come. N is equal to 1, substitute in this. 2 plus 1, 3, 3 by 2. So 3 pi by 2 into p plus q. N is equal to 2, substitute. 2 to the 4 plus 1, 5. So 5 pi divided by 2 into p plus q. And so on. N is equal to 3, substitute. 7 pi will come like this. 7 pi by 2 into p plus q. By observing these solutions, pi by p plus q, pi by p plus q, pi by p plus q is the common difference by observing clearly. So here these are the solutions with common difference. Pi by p plus q and which are in arithmetic progression. Hence proved. They are asking to prove the result now. Which are in AP we can prove. We proved that these are in AP with common difference pi by p plus q. If you want to prove, we can T1, T2, T3, T4 like this you can take. T2 minus T1 if you take, T3 minus T2 also if you do, you will get the same difference. Pi by p plus q only will come, dear students. No need to prove, like this you can give the answer. I hope you understand this video. If you have still any doubts regarding this, you can write to my comment box. I will help you. Thank you all. Jai Hind. Maths with Panindra.